We're going to do a simple example of having some particles fly off of a surface using matter waves to activate them. We'll go ahead and create our particle system, create a thinking, and we're going to create something to represent a car for us. So we'll just kind of, for now, we're just going to make a box. And we're also going to need a wind force. So we'll grab one of those. And we want that wind to be blowing down the face of that car. Okay, we'll switch to this viewport and let's go ahead and get into the TP UI. We're going to set this up so that there are particles being born all over the surface who are then activated and fly off of the surface. So the first thing we're going to do is we're going to create a couple groups, and we're going to call, we'll call this stuck on surface, and then we'll make the second group called fly away. Okay, so in our first dynamic set that we made there, we're going to go ahead and use a generator. We'll make a position born, but we're also going to add a surface. Scratch that. Let's go ahead and we'll use a matter waves. And matter waves, we can tell that to create stuck on the surface particles. We're going to create a pistol shot. We'll pick the object we want to use, which is this guy here. And let's go ahead and scrub to update that. And you can see they still have some speed to them. We'll remove that. Lifespan, we'll just set it really high so we can keep them all there. Let's go to the master dynamic, turn off edit on the fly, and turn on show mesh. And let's go ahead and increase this number. And you can see once we reach a certain number here, up above, looks like what? Somewhere right around 600, it stops creating any particles that we can see. Those particles are actually being generated. You can tell up here where it says total. But what's happening is they're actually being doubled up on the emitters, because we only have a certain number of emitters by default with matter waves. It creates 10 U emitters and 10 V emitters. So we'll randomize that, and we're going to increase the number of emitter locations. This is going to allow us to born more unique particles all over the surface. An easy way to figure out how many unique points you have there is to bring up a calculator and just multiply one by the other. So 168 times 142 means that we have up to roughly 24,000 unique positions. Of course, we're only borning at this point. Let's do 2,000 particles. And we're going to switch this to dots so we can see a little easier. Okay, and so these dots are all being born into the stuck on surface group. We're going to change that group color so we can just kind of recognize it easily, make it a dull red, and then the active fly away will make those, let's do green. And then we're going to need some way to activate these to tell them to go from the stuck on surface group and to go into the fly away group. To do that, we're going to go ahead and in this second rule that we've got, we're going to go ahead and say, okay, stuck on surface particles. We're going to use a condition in mesh. When you're in this mesh, then I want you to go into this other group, fly away. Okay, and of course we need to tell it which mesh we want to use. We don't have one created yet, so we're going to do that next. But we'll hook up the node and get that ready to go. We'll come up here in this little top view, and we'll go ahead and create a let's use a sphere just because it'll add some variation to the direction. Let's put that right there. And then what we'll do is we'll animate. First we'll turn off the master dynamic. We right click to turn these off. And we'll turn on max animate. And I'll say by frame, let's do 80 roughly. We'll have him pass all the way through. Okay, we'll right click to re-enable that. And now it's back on. And so our node we're going to use, we'll pick that sphere, and what we'll see happen is, well, you see right away it makes all of our particles turn green. That's because these we need a position to test against. We need the particle position. Now, something new in tP3, you don't actually have to connect the position, reveal the position, and then connect that position. You could just take the particle and connect it to the position, and it will know that, hey, it's trying to get position information, so the particle goes ahead and provides that position information. You want to watch out in certain cases that the data type it's asking for, sometimes it can go both ways, so gotta watch out. Anyway, so now you can see that these particles all are back to their red color, and then as they go into that mesh, they all turn green there, switching groups. So when these stuck on the surface color, when their position is inside this mesh, the sphere, then it turns this operator on, puts them in that group. Okay, let's go ahead and create another rule. And this rule, let's see, I've been bad and haven't named these as we go along. It's a really good idea to get in the habit of naming these, just because if anybody else ever has to open your file, or even if you do, a few weeks later, it helps in navigating. So this group we'll call switch groups, and this one we'll call forces. And so what we want to say now is we're going to make a rule that's going to affect the flyaway guys, those particles, and it's going to use a dynamics. It's going to use a standard force, and of course here in the standard force you don't see any forces listed, active, deactive, or active. That's because we have to actually, I'll hide that for a second, we have to use the bind space warp to bind that force to TP. And then once we refresh and click on this, now we see that wind appear. We'll activate it to bring it down here in the active list. Turn that guy back on. And so the flyaway particles now are going to be affected by the force. And you can see them kind of float away there now. And we're going to do something here. We're going to use another helper. We're going to use the random helper. Random helper generates a unique value per particle within a range using a random seed, and it can create this new value per call. So anytime it gets called, it doesn't even have to be connected to a particle. If you connect this to like a position born input, you could create maybe we don't want to get too complicated, but basically if it's per call, it will generate a new random number every time it's required. Whereas if you specify the new value per frame animate or iteration, what this means is that per particle it's going to create a new value between these two ranges, or between those two values, every frame or time subsample. And remember that time subsamples are defined in the master dynamic up here under viewport rendering subsampling. So right now we're just set to per frame, so if we set it to per half frame, then of course random is going to generate a new random value every half frame, every iteration there. We'll go ahead and switch that back. We don't need it right now. And let's go ahead and let's take that value and connect that to the multiplier, the force multiplier. So each of these flyaway particles is going to get a unique random value. In this case it's set to per frame iteration. We don't really want that. What we just want is a unique value per particle for his whole life, and so that's the animation setting there. This generates one unique value per particle and it lasts the entire animation. Okay, so now we've got that let's actually have at least some force going, and we'll increase that one a little. So now each of these flyaway particles is going to get a random value between those two values for his whole life, and so they're not all going to move at the same speed, which is going to kind of help vary things up a little there. Okay, that's all right, but let's make it a little more exciting.